Welcome to Module 10, Lesson 1, Simplifying Radicals Using Conjugates. By the end of this lesson, you'll be able to simplify a radical using conjugates when the denominator has two terms. Let's begin by reviewing conjugates. Remember, when we multiply conjugates together, our middle terms cancel out. Let's take a look at this example. 4 plus 3 square root of 5 multiplied by 4 minus 3 square root of 5. We remember that conjugates have the exact same terms but different signs in the middle. Here we have a plus sign and here's a minus sign. So when we multiply this out, the 4 times 4 is 16. 4 times negative 3 square root of 5 is negative 12 square root of 5. 3 square root of 5 times 4 is positive 12 square root of 5. And then we have positive 3 times negative 3 is negative 9. Square root of 5 times square root of 5 is 5. Let's simplify this. We have 16. Our negative 12 square root of 5 and positive 12 square root of 5 add to 0. So those simply cancel out. Then negative 9 times 5 is negative 45. And that leaves us with negative 29. So even though we began with radicals in our initial expressions, we ended up with an integer. This is very useful information that we can use when simplifying. Let's begin by reviewing rationalizing the denominator. Our rule says we're not allowed to have radicals in the denominator, so we learned that we can multiply top and bottom by that radical, then simplify. So I have 8 square root of 5 over 3 square root of 25. Square root of 25 is simply 5. So we end up with 8 square root of 5 over 15. Now let's combine these two pieces of information when we look at our next example. This is 8 over 3 plus the square root of 5. Before, look back, it was 3 times square root of 5. That was one term, multiplying together. Now we have two separate terms, so we can use conjugates to simplify this denominator. If we simply multiply the top and bottom by the square root of 5, we're still going to end up with radicals in the denominator. Using the conjugate will eliminate those radicals. So we're going to multiply by 3 minus the square root of 5 in the numerator and the denominator. Now, when I multiply the numerator, I am not going to distribute that 8. The reason being, I'm going to end up with an integer in the denominator. It's possible that that will reduce down. So let's see what happens. In the denominator, we have our 3 times 3, which is 9, and the square root of 5 times negative square root of 5 is negative square root of 25. Our middle terms canceled, negative square root of 15 and positive square root of 15. Now let's simplify the denominator some more. Our numerator stays the same. Our denominator is 9 minus 5. 9 minus 5 is simply 4. You see that will cancel with my 8. 4 goes into 8 two times. 4 divided by 4 is simply 1. So that gives us 2 times 3 minus square root of 5. We have much smaller numbers to multiply together now. And so our final answer is simply 6 minus 2 square root of 5. Let's look at example number 4. It's a little more complex. Both numbers in the denominator are radicals. Okay, so we can simply multiply by the conjugate of that denominator, which is going to be 3 square root of 2 plus square root of 10, both in the numerator and the denominator. Now this time I will distribute because this is a radical also. So let's multiply 4 times 3 and get 12. Square root of 6 times square root of 2 is square root of 12. Then 4 times the invisible 1 out front here would just be 4, and square root of 6 times square root of 10 is square root of 60. In the denominator, I have my 3 times 3, which is 9, and the square root of 2 times square root of 2 is square root of 4. And then my middle terms, again, are going to cancel out, leave me with just negative square root of 100. Now let's see if we have some perfect squares hiding under these radical signs. Okay, so we have our 12. And square root of 12 can be factored out into 4 times 3, plus 4 times square root of 60 can be factored into 4 times 15, 4 being our perfect square. In the denominator, we can take the square root of 4, so we have 9 times 2. And the square root of 100 is 10, so we have minus 10. So let's simplify the numerator a little more. We can take the square root of 4 here, so we have 12 times 2. Remember, once we take the square root, we're multiplying that by the number that was out front. And then we have the square root of 3 plus 4, and then we're taking the square root of 4 again, so we're multiplying by 2, square root of 15. And in the denominator, I have 18 minus 10. 9 times 2 is 18. Now keep simplifying. What is 12 times 2? 12 times 2 is 24, so we have 24 square root of 3 plus 4 times 2 is 8, square root of 15. Simplify 18 minus 10 and we get 8. Now we see that we can do some canceling. We only cancel if every term can be canceled, okay? Or we can separate it into two separate fractions and reduce what we can reduce. But here all terms are divisible by 8. 8 goes into 24 3 times, 8 goes into 8 once, and 8 goes into 8 once. Okay, so our final answer is 3 square root of 3 plus the square root of 15. Good luck today.